Hello everyone, welcome to another Java video. In this video, we're going to be going over some key concepts that you might have learned in our Java Basics textbook. And then we're going to go through a example problem in Java as well. To start off, we're going to talk about simple things like indentation. It is recommended that we properly indent our code. Every time you indent, let's say you press tab, it should be set so that the code editor you're using should be translating a tab click, or you should be just indenting with 4 spaces to organize your code nicely. Also, as a Java programmer, we end a line with a semicolon. So we will use semicolon to tell Java that we have finished writing this line of code, and the next code will start after this place token. All right, and then we'll talk about 3 characteristics of Java. These 3 things, you just want to remember what Java is all about. Number 1, Java is a high-level programming language. This just means that instead of us writing binary instructions directly to the computer, rather there is a program that translates our English-based instructions that are written for the Java language, and that gets translated to something that our computer can understand so that it can execute the instructions that we write. And because of that, Java is also a compiled language where after we write a Java code, there is a compiler program for Java. So when you run a Java program, the compiler will then translate our entire instructions that we wrote in a Java file and then let the computer execute that code. Right. And lastly, something you'll learn in the future is that Java is an object-oriented programming and language, and you have been dealing with objects such as strings and scanner. They're all objects, and you get to create your own in the future. But all you have to know is that Java is object-oriented. All right, and then we're going to talk about these 3 data types: int, double, and string. Okay, and they all have their sizes in terms of memory, and int is going to be 32 bits. So int is a primitive data type that is built into Java and is used to represent positive and negative values, whole numbers to be exact. And the bit size determines our maximum size of number itself. So what we're allowed to generate is 2 to the exponent 32 minus 1, all divided by 2, so that the first half, when we divide by 2, is the positive integers from 0 to that number, and we go from 0 to negative of that number to help us represent a maximum negative or the smallest possible value as an integer. Double. It also uses 32-bit. We are representing positive and negative real numbers. Strings, there is no size limitation because it depends on how long a string is in this case, and there are, yes, hard limits, but we won't get into that detail. All you need to know is that it's going to be dependent on the size of your string that you've inputted, and it is used to represent text, which is alphanumeric, special symbols, and so on. And the reason why we have these different data type is that they handle different situation when you're programming, so that like we can't add 2 strings together to do and create like a bigger number. For example, we can do that with integers and double. So anything that involves arithmetic, you should be using int and double, especially if it requires a division, then you should be using a double. But if you're only dealing with text and you just have to output them or change the character or something like that, you can use a string in that kind of scenario. And these are all stored in a variable. Variables are labeled containers that hold data, and we can refer to them, we can reassign them with new values, and maybe we can change the inner contents of it when we learn some new data types later on. The format would be you state the data type of what the variable should be, you create a nice little name, it shouldn't start with a capital, and you assign a value by using an equal sign. That's why we call the equal sign a assignment operator. Some rows variables can't share the same name. So if you have multiple variables being created in this format, they can't share the same name. They should not start with capital letters or numbers and can't contain special characters. They can't especially contain white spaces. So if you have multiple words being adjoined, you should use either underscore, arrow, or a camel casing system. With all that, if we have data types and variables, we can do input and output. For us to do input, as in grabbing a value from a console, you would need to import a scanner and create a scanner object so that we can use sc.nextLine. For us to output a textual message to the console, we use a function called system.out.println that will help us output string data to the console. Right. And whenever you do use a scanner, it is recommended that you close the scanner because you are trying to prevent something called a memory leak. some really nice functions that are built into Java that you can reference to when you want to convert strings to numbers. First, you can use integer.parseInt with that capitalization, and you give it a string. It will try to convert that string to an integer if possible. And if the string only contains numeric, positive, whole, or negative values, it will convert that to an integer. In the same sense, if you want to create a double based off a string, if it's a numeric text, then we can generate a double value by doing double dot parse double, and that will convert our string to a double. Okay, we convert string data to integer double whenever we need to convert them, and most likely do arithmetics. Lastly, there is a problem-solving method that we've learned so far called the IPO model, which stands for input, processing, and output. IPO creates a plan on how the problem should be solved with a program. So this really helps us break down a problem before coding, which is a really nice skill to have. And this leads you to reducing number of errors that you should make on your code because you're not coding blindly, but rather you're just translating your English-based written plan into Java code. So that was a nice little blitz through of what entailed in Java basics. What we're going to do is the following. We're going to be looking at this question, CCC 2008 J1 question. We're going to be calculating the BMI, and the BMI is a calculation to assess an adult's health based on their height and weight. And so there is this nice little handy formula where BMI is equivalent to weight divided by height multiplied by height. Okay, so we'll start with our input, processing, and output. And we'll just generate a simplistic model of what to do in this situation, right? So for input wise, we need two variables to store height and weight as numeric inputs. They should be double since the formula requires division. It's just a really good note that if anytime you see a division that needs to happen, it is really safe. Just keep your variables as a double value. So we're going to do that right now. We're going to say double height is equal to a double dot parse double. And we're going to have sc dot next line. That's going to grab the next input before an enter key is press, and we'll convert that to a double, hoping that it is a numeric value. And then we're going to do the same thing, but we're going to grab their weight. So copy that over, and it's going to be their weight, and grab their value. And if you wanted to, you don't have to for the competition for CCC, but you can write something like enter your height and weight within a system.println so that we can give some sort of an information or instruction for the reader when they're interacting with their program within the console. So input's done. For the processing part, what we want to do is store the BMI calculation in a variable that we'll call it a double variable. And the formula is BMI is equal to weight divided by height multiplied by height. And that should all be within a bracket like so, because we want to do calculate the denominator first, then do our division. So let's execute that. We're going to say that we're going to have a BMI variable, and we're going to set that equal to our weight divided by height multiplied by height. And to do multiplication, it is an asterisk symbol. To do a division, it is a single slash, and put a semicolon. There, we have our BMI. Now, we haven't learned how to determine so far in terms of how to do conditional statements in Java. So we're not there yet. So we're going to ignore this part. We're just going to output what our BMI is, and then I'm going to show you what that would look like in our future unit. So we can say system.println your BMI is, and I'm going to use a plus to add on the value of BMI to this string in our print statement, like so. So we have system.out.println like that. Cancel. Escape to close like that. Awesome. So we have our BMI. So we have all our code written. Let's see this code running. So we're going to be entering our height and weight. We'll say we are in probably meters. We'll say 160, and our weight is going to be, let's say, 65. And that's our BMI. That seems way too low. Okay. Most likely they want us in, what was it measured? In height in meters and weight in kilogram. Oh, okay. So we should enter a value like, let's say 1.6, and our weight can be like 50. Okay, so our BMI is 19. So if we're between that, we should be normal weight. So if we wanted to, based on that calculation and output that they're either overweight, normal weight, or underweight, we learn how to do conditional output as well. Output using if. So this will be in the future. For the basics, you need to know how to do this. But in the future, you can just write a little simple if statement to say that, well, if you're referencing a variable called BMI, and that value is greater than 25. So we can say 25.0 because we're dealing with double variables. We can do system.out.println overweight. Okay. Then we can write an else if to say that if it's between 18.5 and 25, but I'm going to be a little lazy. I'm going to hit the underweight first. We're going to say BMI is less than 18.5. We're going to say that they're underweight. So we'll copy this over, under. Wait, right. Now, the reason I did this is because I wanted to keep my conditions simplistic, because if it wasn't this, and if this part wasn't also true, we know for sure that they're in between those two values inclusively. So we can just say all else, they are a normal weight. Okay, so let's try our program now. So let's say, for example, someone was 1.8 tall with 80 kilograms, and their BMI would be 24, so they'll be a normal weight. And I executed all this because our first two conditions were false. But regardless, for the basics chapter in our textbook, you being able to do this much of code is somewhere you should be, and it should be something comfortable for you within your coding career so far. And this was just a preview of what's going to happen in the next chapter of your textbook readings. And as always, thank you for watching and stay classy.